This is some higher maths exam practice, and it's in the form of a homework. It's 9 questions, so it'll be good for studying if you're going to be studying for prelims or you're trying to sharpen up your Unit 1 skills. So what we're covering here is some straight line work, some recurrence relations, we're going for some differentiation, and also there's some composite functions in here. So 9 questions, and I'll show you where the marks are as we go through the questions. Okay, so we'll just get started, right? Right, first question. Here we go. Okay, so given f of x is equal to 2x cubed minus 7, find the value of f dashed 2. So if I can see that dash that's sitting there, I know I'm going to have to differentiate. So I'm going to go ahead and do that. Okay, so let's find f dashed x first of all. So that's going to be 6x squared, and the 7 will go to 0. What I'll then do is I'll substitute the 2 in, okay, and I'll show it as I'm going to substitute 2 into that differentiated equation. And what I have is 6 times 2 squared, which will give me 6 times 4, and the answer for that will be 24. Right, marks for this one we're going to give is 1 for differentiating correctly, second one for getting the 24. So that was out of 2 marks. Next question. Okay, again, non-calculator question. So a curve has equation y equals 5x cubed minus 12x. What is the gradient of the tangent at the point 1 minus 7? So important thing here is I'm going to need my x value for this one here. I don't really need the y value to work out the gradient. I know that when I differentiate, that'll give me a gradient equation. So we'll start with that. So y equals 5x cubed minus 12x. Going to differentiate. Remember, that gives me a gradient equation. Okay, so differentiating, that should give me 15x to the power of 2, and that'll be minus 12. So when I have to find the gradient, when I'm at this point here, the x value is the important one for me. So what I'm going to do is I'm going to substitute a 1 into that equation. So 15 times 1 squared minus 12. That'll give me 15 minus 12, so that should give me a gradient of 3. Marks for this one, what we'll do is we'll go for 1 mark for differentiating correctly, 1 mark for just working out the gradient. Okay, so that's another 2 marks there. Next question. Okay, what we have here is a sequence is generated by the recurrence relation un plus 1 equals 0.4 un minus 240. What is the limit of this sequence as n tends towards infinity? Right, so what I'll do there is I'll just start with the limit equation. And just before I do that, what I'll say is I'm going to say that a limit exists, okay? So a limit exists. And the reason for the limit existing is because that there lies in between 1 and -1, or -1 and 1. So that's has got a limit, okay, and that's what we're going to do. We're going to use the limit equation. So let L be the limit. So L is going to be equal to, so it's going to be B all over 1 minus A, just as a straight equation from there. So what we've got is we're going to substitute some values in. So this will be my B value here. So I've got minus 240. On the bottom I've got 1 minus A, and this is my E value, which is 0.4. From there what I'll do is I'll just work this one through. So I've got minus 240, that's all going to be over 0.6. From there, for that type of fraction, what I'd like to do is multiply out by 10. So I'll multiply by 10 there, and I'll get a 6 on the bottom. So let's get rid of the decimal, and multiply by 10 on the top as well, on the numerator, and that should give me minus 2,400. From there, 6 into that will give me minus 400 as a final limit. Okay, marks for this one here. Let's go for 1 mark for substituting correctly into an equation. Okay, for the limit, a correct equation, and 1 for calculating the limit. So again, just 2 marks for that question there. Question 4 this will be, and it's question 11 on the sheet. Right, what is the derivative of 4 minus 9x to the power of 4? All of that bracketed to the power of a half. Right, so I'm going to have to use a chain rule when I'm doing the differentiation. So what I'll start with y is equal to, and I'm going to say it's 4 minus 9x to the power of 4, and that's all to the power of a half. Now, when I'm working with the chain rule, when I differentiate, what I'm going to do is I'm multiplying the bracketed term, okay? I'm going to have a half here times a 1. Bracketed term is going to stay as it is, and I'm going to reduce the power by 1, just like I would normally do with differentiating. So that's to the power of minus a half. The part that's in the bracket is just exactly what's there, so that's going to be 4 minus 9x to the power of 4. Okay. Then as the chain rule, I'm going to be multiplying by the inside of this bracket differentiated. So 4 would go to 0, so that's gone. And then 4 times minus 9 is going to give me minus 36. X to the power of, and I'm going to bring that power down by 1, that will be to the power of 3. What I'll do is then I'll just tidy this up a bit. So I've got a half out here, I've got a minus 36 here, so if I gather the numbers together, that should give me a minus 18. I'll bring the x cubed to the front, minus 18 x cubed, and then the bracketed term that's there, 9x power of 4, and that's the power of minus a half. Okay. Sometimes we're asked to write that with a positive power. I'll just go forward and do that. We haven't in this question. So on the top, on the numerator, would be this part here. This part's all to the power of minus a half. Put that underneath, 4 minus 9x to the power of 4. It's now to the power of a half. And if I really wanted to tidy that up a bit, what we'd go for is we'd put that into a root form. That would be the square root, 4 minus 9x to the power of 4. Okay, so marks for this one. We're just going to go for 2 marks for this one again. I'm going to go for 1 mark here for getting this part correct here, so differentiating out that bracket. And the final mark I'm going to get for this line that's here. I don't need to take it any further to there, so just 2 marks for that one as well. Okay, for this question here, so what we've got is a recurrence relation. I'm just going to see if I've got a calculator. Hopefully I do. Yeah, got one. Right, so this is a calculator question, and we've got a sequence is defined by the relation, recurrence relation, un is equal to un. Un is equal to 0.9 un minus 1 plus 2, and we've got a kind of starting value of u1 is equal to 3. And what we have to do first of all is to calculate the value of u2. So that's the next number in this sequence. Right then, so what I'll do first of all is I'll just bring this relation down. And our starting number was u1 is equal to 3. So what I'm going to do is I'm going to substitute the u3 into this value here. I'm going to work out what u2 is. So the way I do that is I'm going to work out 0.9 times whatever the previous value is. That was 3. Plus 2, and then I'll just work that one through. So that's going to be 2.7. 2.7 plus 2 is 4.7. Okay, so that there is part A completed. So that'll be a 1 mark for that when we get that. Part B, what is the smallest value of n? So this number here is the n value that's here, for which un is greater than 10. So what we'll do is we'll work this through until such times as we get beyond 10, and that will be my value that I'll pull from here. Let's go for that. So u3 is equal to, so it's going to be 0.9 times u2, which is 4.7, plus 2, and that's going to equal some sort of number there. I'm then going to go for u4 is equal to u.4, so 0.9 times the value that's going to appear there, and I'll add 2 onto that, and I'll continue that going until I get to the number I'm interested in. Okay then, so what I've got here is, so this value here is going to be 6.23, this value here 7.607, okay, so in here 6.23, and I'll just do that on my calculator as I go forward. So 0.9 times this previous value, what that should give me is 8.8463. U6 is going to be equal to 0.9 times 8.8463 plus 2, and that's going to be equal to 9.96167. U7, so we're still not exceeded the value of 10, so I've got to keep going. Just probably this one will do it, I would think. 9.96167 plus 2, and that should give me, yep, that's going for 10.965503. So that has now exceeded the value. So the smallest value, so it's the smallest value of n, for which un is greater than 10 is n equals, and there's the number there, so it's a number 7, okay? So n is equal to 7. That there is part B. For part C, what we're going to be doing is we're going to find the limit of the sequence. So for the limit of the sequence, what I'll do is, for that, I'll just say that a limit exists. And the reason for the limit existing is because that number there, the 0.9, it lies in between -1 and 1, okay? And we'll let L be the limit. Right, start with the limit equation. So that L is going to be equal to B all over 1 minus A. What we'll do for that, we'll substitute some of our values in. So the value for B is this number here, so it's the 2. So it's 2 is going to go there, so that's the value of B, and the value of A is the 0.9. So it's going to be 1 minus 0.9. From there, I've got 2 all over 0.1. And to make it a wee bit simpler to work out, I'll multiply by 10 top and bottom. That should give me 1 on the bottom, 20 on the top. So that limit there looks as though it's 20. So the limit of the sequence is 20. Okay, let's see some marks for this one here. Right then, so the first mark for part A, I'm going to just go for 1 mark for 4.7. For B, I'm going to go for a mark for getting the 2 of these correct. I'll get a mark for stating that n is the number 7. That's a number that's greater than 10. Okay, for un is greater than 10. I'll go for substitution into the limit formula, and that'll be a mark there, and calculating that limit is going to be the 20. Okay, so that's 1, 2, 3, 4, 5. So that's 5 marks for that question that's there. Okay, let's move on to the next one. Okay, so what we've got is we've got a couple of functions. We've got an f of x function, a g of x function, an h of x function, and what we've got is we've got to find the formula for k of x, where k of x equals f of g of x, okay? So it's a composite functions question, and what we'll do is we'll just work that one through and see what answer we get out at the end. Okay, so for part A, right, so what we'll do is we'll start off with k of x is equal to, and it's f of g of x, okay? So that's what I'm going to state, because that's what I'm going to have to work out. First thing that I'm going to do is I'm going to substitute in the g of x function inside that bigger bracket. So that's going to be 3 minus 2x, so that appears there. Then what I'm going to do is I'm going to look at the f of x function, and wherever I see the x, I'm going to substitute that bracketed term into there. So there's the 2. Inside there, where x is, I'm going to put 3 minus 2x, and then I've got a minus 1 that's sitting there. What I'll do is I'll multiply that through, so it's going to give me 6 minus 4x minus 1. So finally, what I should get is 5 minus 4x. And there's my first part of the question complete. I'll then go for part B. Part B, find a formula for h of k of x. So I'm going to have to use this function here because that's my k of x function, and I'm going to use this h of x function. So it's h of k of x, okay? H of k of x, okay? So that's going to be equal to the h function, and I'm going to substitute in there this function here, the k of x. So it's going to be 5 minus 4x. What I'm now looking at is I'm looking up here at the h of x function. Wherever I see x, I'm going to put in that bracketed term is going to go in there. That's what's going to happen. So here we go. We've got a quarter. It's a quarter that's there. Opening it up, there's that 5 is going here, minus, and then what we're putting into this bracket is 5 minus 4x, okay? 5 minus 4x. And we need to be careful with negative numbers here, because that's where we'll get tripped up a bit. Let's multiply this bracket out here. Remember that negative there is a -1 sitting there. So I need to multiply these things out by -1. So this is where I would think that the mistakes would be made. So there's a 5 there. That'll be -5. Minus times a minus will give me a positive 4x. If I gather up what I can here, 5 take away 5 is 0. So what I've got left inside that bracket is just 4x. And a quarter of 4x leaves me with x. And that should let me know something. That should help me with part C. So part C, what is the connection between the functions h and k? Well, if I substitute an x into that equation and I get an x out, well, they must be inverses of each other. So, statement, the functions h and k are inverses. And I'll just say of each other. Okay, that'll be that question done. Okay, for that last part, I'm only going to get 1 mark for that part there, okay? But I'm only going to get the mark if this works out to be an x. That's the only way I can get that mark. If that's something else and you state that, unfortunately mark gone, okay? Marks for this one, I'm going to get a mark for substituting that 3 minus 2x in there into an f of x function, and finally getting that coming out at the end. Next one will be substituting into that h of x function and getting the x out there. So this one here out of 5 marks, okay? Right, okay, non-calculator that one was again, not needed. Non-calculator question coming up again. Okay, so find the size of the angle A. So what we're looking at is this angle that's sitting in here between the x-axis and the line that we've got. We've got a couple of points on the line, okay? And what we're trying to find out is the angle. So if I'm looking at that type of question, to find out the angle, well, I know a small formula that's going to help me out, and it's going to be tan A is going to be equal to m, it's going to be equal to the gradient. So if I can work out the gradient first, that's going to help me with this question. So let's work out the gradient. So my gradient is going to be equal to y2 minus y1 all over x2 minus x1, since I've been given 2 points to work through. Right, so I'm going to start with this point here, okay? So that's going to be my second point, that there is going to be my first point. So I've got 2, take away minus 1. So that's going to be a positive, isn't it? I'm going to add that. 3 root 3, whoops, pen didn't work there. 3 root 3 minus 0. So for this part on the top, I've got 3, and I've got 3 root 3 on the bottom. To simplify down, what I can do is I can cancel these 3's out, or I can divide the top by 3 and get 1. Divide the bottom by 3 and get a 1 that's going to be there. So that's going to give me a gradient of 1 all over root 3. Okay, remember that 1 on the numerator there. Doesn't disappear. Okay, I'm again going to then use that small formula that I know. So I know that tan A, I'll call it A, is going to be equal to the gradient. So I've got tan A is equal to 1 all over root 3. So I know that for this one here, I'd be trying to think, if I was trying to use a cast diagram, I'd be looking for a positive value, because that's positive. positive or negative. And what I should be getting is, I should be getting a value in there and a value in there. For this question, I'm only interested in the value that comes from the first quadrant there, because that will give me my correct answer. And that's going to be the positive direction from the x-axis to the line. So it'll give me that distance there, or that angle. So A is equal to the inverse tan of 1 over root 3. Because it's a non-calculator question, I need to think about my table of exact values. And on the table of exact values, I should get an answer of 30 degrees coming out of that one there. Marks for this one, I'm going to go for 3 marks. I'm only going to give 1 mark here for getting the gradient correct. I'll get 1 mark for substituting into the gradient, 1 mark for getting the correct angle coming out of that. So that one there out of 3 marks. Okay. Right then, so let's go for, have we got any left? 6. I think that's all the questions I have here. Okay. Right, okay. So what we'll go for next is we're going for this question here. Okay. Okay, I don't have a separate sheet for it, but I'll just do it on a plain bit of paper. So we've got a triangle ABC, has vertices, A is minus 4, 1, so there we go there. 12, 3 is B, 12, 3, and 7 minus 7 is going to be C. Find the equation of the median, CM. Okay, so we'll try and work that one out. So I'll work out the median at this side here, okay? So you can see the working that I'm doing. Right, here we go. So to find out the median, if I look at this one here, the median is in the middle of that line there. So that's a midpoint of A to B. So that's the first thing that I'm going to work out. So I'll work out the midpoint of AB. So the way I work out the midpoint is take the mean of the x values. So minus 4 plus 12. That'll all be over 2. I'll just be dividing it by 2. And 1 plus 3 divided by 2. So that should give me, that's going to be 8 divided by 2 is 4. And 4 divided by 2 is going to be giving me 2. So I've got 4, 2 that's going to come out there as my midpoint. So that'll be my first mark, I'm sure. Next mark, I'm going to work out the gradient of that median. So that's from C to M. So the gradient of C to M is equal to y2 minus y1 all over x2 minus x1. Let's see, so that point there was now 4, 2. And what we'll do is we'll go for 2 minus 7. Okay, that'll give me 9. And I've got 4, and that's the x coordinates going to go next, minus 7. That's there. So that'll give me a 9 on the top. And on the bottom there, I've got minus 3. So that should give me a minus 3 gradient. And I can look at the diagram that looks like a negative gradient that's there as well. So I'm possibly on the right track. Sometimes the diagrams aren't drawn particularly good, or really they're not drawn to help you with that. Right then, so I've got a gradient of minus 3, and I've got a point on the line and another point on the line, okay? So what I'll go for is, I'll just go and I'll work out what the altitude is. What I'll do is I'll use that point there, 2 positive numbers. So I've got y minus b equals mx minus a. What I'll do is I'll substitute in there. This is my b value that's here, this is my a value that's here. My gradient I've worked out was minus 3. And what I've got is x minus 4. So there's the values that I've put in, and all I need to do is to work that through. So I've got y minus 2 is equal to minus 3x plus 12, 2 minuses multiplied together, and then I've got y is equal to minus 3x, and that will be plus 14. Okay. What I'll probably do is just prepare this for simultaneous equations. So I'm going to grab the x values over to this side as well. So I've got y plus 3x is going to be equal to 14, and that'll be my equation number 1 that I'm going to use, okay, when I do simultaneous equations, when I find the point of intersection, this point here. So that's part A, okay. Marks for that one there. 1 mark for getting the midpoint. 1 mark for getting the gradient and 1 mark for getting the correct equation of the line. Okay. Right, next part we're going to go for is we're going to find the altitude. So if I look at the altitude, that comes from A. So the AD is the altitude, this one here. So what I'm really interested here in is finding the gradient of the line. I already know that point, and it's very rare that we find out the point D, that point that's there. We don't usually get that. What we do is we find the gradient of BC, and then we flip it over and change the sign, and that will give us the AD gradient, and we'll go from there. Right, let's go for this one. So for part B. Right, so it's the altitude. So I'm going to find the gradient of BC. It's y2 minus y1 all over x2 minus x1, and we're just going to choose that value there. So I've got 3 minus 7, and I've got 12 minus this 7 that's here. Okay, so what I've got there on the top, that's going to be 10 all over, and that's going to give me 5. So that should give me a gradient of 2, and it looks like a positive gradient, so that might be okay. I'm then going to find out the gradient of AD, and that's perpendicular to this gradient. Perpendicular, it's got right angles. So all I would be thinking of is that that's got a 1 underneath there, so I'm going to flip it over, 1 over 2, and I'm going to change the sign from positive to negative. And really why I'm doing that is since the gradient, these two gradients multiplied together, they equal minus 1. That's one of the properties of a perpendicular gradient. Okay, from there I'm going to substitute that gradient and this point A, into the equation of a straight line. Right, here we go. So I'm going for y minus b, so that's going to be minus 1, is equal to the gradient minus half x minus 4. That'll work out to be a positive. To get rid of that half, I'm going to multiply by 2 over on this side here. So both things I'm going to multiply by 2. And then on this side, I'm going to multiply by the minus 1. So that'll give me a minus x value. That'll be plus 4 times a minus 1 will give me a minus 4 that will be there. And then what we'll do is we'll just work this one through and gather it up. So I've got 2y is equal to minus x, and that 2 coming over will make that minus 2 there, because that'll be a positive 2 coming over. And that would probably be my equation of the line. What I'll do is I'm going to gather the x's over to the left hand side again. So 2y plus x is equal to minus 2. Well, that there is going to be my equation number 2 that I'm going to work with. Right, let's see the marks for this one. So 1 mark for getting the gradient of 2. Don't leave it as 2 over 1. You'd lose a mark for that one there, so it's got to be a 2. This one is minus a half for a gradient, that's another mark, and a mark for getting the equation of the line. Point of intersection, let's do that by simultaneous equations. So part C. We'll say it's by simultaneous equations. Right, so I've got my first equation here, so that's going to be y plus 3x equals 14. That's equation number 1. And my equation number 2 is 2y plus x is equal to minus 2. That's equation 2. Right, so I can't do anything with them right away as they are. What I'll do is I'll multiply equation number 1. I'm going to multiply that by 2. And what I can then do from there is try to eliminate something from the equation. So that will give me 2y plus 6x is equal to 28. That gives me equation number 3. From there, what we'll do is we'll be able to eliminate these. If they're the same sign, okay, I'm going to subtract. Okay, so I'm going to start with equation number 3. I'm going to take equation number 2 away from that. So equation number 3 take away equation 2, y's have gone. 6x take away x gives me 5x. 28 take away minus 2 gives me 30. So x is equal to 6. There's my x value that comes out of there. I'm going to substitute that 6. So substitute x equals 6 into, and I'll go for my equation number 1. So my equation number 1 is this one here. So I've got y plus 3 times x, which is the 6, is equal to 14. So y is equal to 14 minus 18. So y is going to be equal to minus 4. So I was asked for the coordinates of the point of intersection. So the point of intersection is going to be 6 for x minus 4 for y. Done. Okay. Right, so marks for this part here. I'm going to go for 3 marks for it. I'll go for 1 mark for scaling the equations to make sure that we can work them through. 1 mark for the x value or the y value. And the final mark for the coordinates, must be for the coordinates there. So this question here, we've got out of 9 marks. Okay, out of 9. Okay, last question we've got to do. And it's this question here. Okay, so it's a non-calculator question. And what we've got is, we've got a curve, has the equation y equals 3x squared minus x cubed. Find the coordinates of the stationary points on this curve and determine their nature. See stationary points and their nature. I'm going to have to do a nature table. I'm going to have to differentiate to try to work out the stationary values, my x values, work out my y coordinates that are associated with them, and find out if it's a maximum or a minimum. So that's what I'm going to be doing for part A. So let's go ahead and we'll work that one through. First thing, right, so let's see if you can see this on the screen. There we go. If I move that over to there, here we go. Right, part A. Okay, part A. Right, so first thing I'm going to do is write down my equation. Y equals 3x squared minus x cubed. What I'll then do is I'll differentiate it. So dy by dx is equal to 6x minus 3x squared, okay? So, and from there, I'm going to be writing for stationary points, for SPs, dy by dx equals 0. So I'll substitute a 0 at this side. What that tells me is that my gradient's flat, and that'll tell me where a stationary point or a turning point is going to be. What I'll then do is I'll factorise this here to try to work out my x values. So I can see I can take out 3x out of a bracket. 3x times 2 would give me the 6x. That'd be take away x would go there, okay? From there, I've got 3x equals 0. So x equals 0. So there's my first x coordinate there. And from here, I've got 2 minus x equals 0. So 2 is equal to x. So x is equal to 2 from that point there. Okay. Right, I'm going to find my y coordinates. That's the next thing I'll do. So my y coordinates when x is equal to 0. So y when x equals 0 is going to be straight back into the y equation. Okay, that's where I'll find out what y is when I know what I'm going to substitute in for x. Okay, so y when it's 0, it's 3 times 0 squared minus 0 cubed. And that will work out to be 0 minus 0 will give me 0. So that will give me one stationary point is going to be 0, 0. Okay. From this point here, when y is equal to 2, and I substitute that into the equation, if I square that, it gives me 4. 4 times 3 gives me 12. I'm going to subtract from that 2 cubed, which is 8. And from there, what I should get is an answer of 4. 4 coming out. Let's see if I got that right there. Let's see, so it's 3 times 2 squared. Yep, so that would be my y coordinate of the stationary point. So that's going to be, just checking this, 4 times 3 is 12. That's going to be 8, so that's going to give me 4 that comes out there. Okay, so the value here is 2, 4. So that's going to be my stationary point that works out from there. Right, so I then have to do my nature table, okay, to find out the nature of the stationary points. So first thing that I'm going to do is I'm going to make up wee table. So I'll just draw it freehand. There we go. X values coming in here. So I know that I'm starting off with a 0 as my first x value. So I need to know what the curve's like when it's coming along to 0. I need to know what it's like when it leaves 0. And by that I mean what's the gradient like, what shape's it like. And then from there I'm going to come along to 2. And then I want to know what it's like when we go beyond 2. to know what that curve's like. And that will tell me if that's a maximum, minimum, or a point of inflection. Right, so what I'll do here is I'm going to take this part here. See this part of the differentiated equation? I'm going to use that rather than that part up above. I can use either of them, but that's the one I'm going to use here. And what that's going to give me is that's going to give me my gradient, or the shape of the curve. Okay, so that's dy by dx. Okay, after I've done that, I'm going to work out the shape of it, and I'll make a final statement after that. Right, so where it's 0, I know that it's 0, okay, the gradient, and where it's 2, I said it was 0, so that's what I started off with, 0. So if I substitute a number before 0, minus 1 for talk's sake, so minus 1 going into there, that would give me a negative, so that would be minus 3 times, and if that's minus 1 that goes in there, that's going to be minus a minus, that's going to be a positive, so that there is going to be a negative shape on my curve. If I substitute in 1, that's a number in between 0 and 2, 1 going into 3 times 1 gives me 3, which is a positive, and if I put a 1 in here, 2 minus 1 is going to be a positive, so positive times a positive gives me a positive gradient. If I substitute 3 into here, 3 times 3 is going to be 9, which is positive, and if I substitute 3 into this part of it, that's going to be give me minus 1, so that's going to be a negative. So positive times a negative, that gives me a negative. So I know that the shape of the curve that I'm going to draw is going to be negative. It's going to get to 0 and it's going to be turning. It's going to come up here, positive. It's going to get to 2 and it's going to be flat, so it's a stationary point, and then it's coming down like that. So there's the shape of my curve. So what I would also say is I'd just make a quick statement. So the curve is a minimum, has a minimum turning point at, and what we'll do is I'll look for the coordinates, so it's 0 there, okay, and it's 0 here, okay, 0, 0, and the curve has a maximum turning point at, and it's this point here, so it's 2 for the x coordinate, and it was 2, 4 that kind of matched up with that, okay, 2, 4. Right, so that's me completed part A, which was, you know, it's a bit of a slog getting through there, but there's loads of marks to be gathered up as we go through this part here. Right then, so let's go for part B. I'll just move across a wee bit, and what we'll do is we'll do part B here, and hopefully it fits in. If not, I'll just go down onto another page. Right, for B, what we have is we have to state the coordinates of the points where the curve meets the coordinate axis and sketch the curve. So first thing I'll do with that is I'm going to let x equal 0. That'll tell me where the curve cuts the y-axis. So I'm going to substitute 0 in, so that's 0 going into the initial equation, the x is equal to, the y is equal to equation, and that's going to be 0. So that there is the point 0, 0, and that was a kind of point that we worked out earlier on. That was one of the points that's a stationary point, so I know it's going to turn on the axis. I'll then let y equal 0. If I let y equal 0, I'll substitute a 0 into this side, and what we've got is we've got 3x squared minus x cubed. What I'll do is I'll factorise that out. So to factorise that, I can take x squared outside the bracket. So that's going to give me 3 minus x. And from there, I can work out my, my points where it's going to cut over the axis. So that one there, x squared equals 0. So x equals 0. From here, 3 minus x equals 0. So x equals 3. So my coordinates are going to be 0, 0. And that's the same as that one there. So that's been a coordinate that's come up a couple of times. And this coordinate here is 3, 0. Okay. Right, so from there I'm going to have to sketch the curve. So I know the shape of the curve, I know where it cuts the axes, I know the coordinates of the stationary points, and from there I can just go ahead and sketch that curve. Right, so don't have a ruler. So what we'll go for is here. I'll just do this down the bottom here. Right, so here's my curve going to be drawn. And what we'll do is we'll go along here. Okay, so I've got my x coordinates going along in this direction, got my y coordinates up in this direction here. Where they cross over, that's 0, and that's going to be an important point for me. So I'll put in the points where it crosses over the axes. So I've got 0, 0 from that one there, there's 0, 0, 0, 0 from there, and 3, 0 from there. So if I can just kind of move along, 1, 2, 3, 4, 5. So there's 3, 0 there. So that's going to be 3. Okay, that's where I'm going to cut over the axes. So what I've also got is I know the shape of the graph. I know it's going to be turning at 0, 0. So if I go, just move over a wee bit. So it's this point here I'm going to take, and then I'll take the point 2, 4, and I'll draw that one in next after that. So 0, 0, I know that it's turning and it's a minimum turning point. So there's that one there. Okay, that's me there. I know that I've got a maximum turning point at 2, 4. So if I go up 1, 2, 3, 4. So how about going along to there? 2, 4 would be there. So that point there is the stationary point 2, 4. And I'm going to come back through here. Okay, so I know that's going to be turning there. It's going to be quite a sharp turn back through the 3. So if I can draw that, I'll come through here. There we go, there. Join that up from there to there. And from there to there. Okay, so there we go. So I've labelled up the stationary points, labelled up the axis intercepts, and that should be me complete with my curve. Right, let's see where we get the marks for this last question. So marks are going to come from, let's go over to the first part where we were doing the stationary points, differentiation, etc. First thing, differentiating. I'm getting 1 mark for that there. I'm going to take 1 mark for setting dy by dx equal to 0. So I can set it there or I can see it there. I'd rather it be in both places, but that's where I'm going to get that one. I'm going to get 1 mark for factorising that out. Okay, factorising this part here to there. And I'll get 1 mark for getting my x coordinates. I'll go for 1 mark for getting my stationary points, okay, from there. So that must be the 0, 0, whoop, let's move that along a wee bit. The 0, 0 and the 2, 4. So from there, 1, 2, 3, 4, 5 marks so far. I'm going to get 1 mark for setting up the nature table correctly. And by correctly, I mean that I must have dy by dx in here, or the formula for dy by dx. And the final thing is for getting and making the statement that I've got a minimum and a maximum at the correct locations there. So that's going to be 7 marks for part A. For part B, I'm going to go for, what will I go for? I'll go for 3 marks. I'm going to go for 1 mark for getting all of the points that were necessary for the axis intercepts. And for the graph, I'm going to get 1 mark for the correct shape on the graph and 1 mark for making sure that the points have been correctly placed. So that'll be for the points have been correctly labelled, and I'll get 1 mark for the shape. That would be, it's there. Okay, correct shape. And I'll just put that in there, that's a 4 there, although I've mentioned the coordinate there. Right then, so that one there should be out of 7 marks there, 3 marks there. So that question there was a 10 marker, so that's quite a beast of a question. Right, so that's the homework complete. Should be out of, I think I counted it up correctly as being 41 marks for that. Unfortunately, I had to squeeze things into the last 2 questions there, but hey, that's okay. That's the way it goes sometimes. Right, so anyway, hope this has helped with your studying, and I hope it's helped with you maybe understanding some of the questions from the homework. And also, it should really help if you revisit this, try the questions again when you're going up for your prelim or your final exam. This should help you kind of get a better mark as you go forward. Good luck in your exams, and good luck with the homework. Cheers for now.